हेलो बच्चों, आज हम लोग एक टॉपिक डिस्कस करने वाले हैं जिसमें बच्चे बहुत ज़्यादा प्रॉब्लम फेस करते हैं। दैट इज़ सब्स्टिट्यूशन वर्सेस एलिमिनेशन। मतलब ये कि कब रिएक्शन में सब्स्टिट्यूशन होगा और कब एलिमिनेशन होगा। इज इट क्लियर? सो in this case, the first thing that we should understand over here is that substitution and elimination are competing reactions. Fine. Whenever the reactant reaction involves substitution, the attacking species involves behave as nucleophile, whereas when elimination reaction takes place, the attacking species behave as the base. For example, if I consider a reaction that is tertiary butyl chloride. Fine. If I react it with water in this case, what we observe in this case, we observe कि जो product मिलेगा वो क्या होगा? It will be the substitution reaction where water is behaving as the nucleophile in this reaction, and the reaction is of course taking place through carbocation as an intermediate. But when I do the reaction of the compound CH3 CHBr CH3 with RO minus alkoxide, what is the product forms over here? It forms the product as CH3 CH double bond CH2. It is the alkene that is formed. So the important thing over here is that this was the first reaction which we have written is a reaction called as the substitution reaction. In this substitution reaction, H2O is behaving as nucleophile. Whereas when we consider the second reaction, it's an elimination reaction forming alkane, and RO minus is behaving in this elimination reaction. It is behaving as a base over here. Fine. So but important बात ये है कि जो न्यूक्लियोफाइल होते हैं और जो बेस होते हैं उनके लिए जो फैक्टर है जो उसे न्यूक्लियोफाइल बनाता है, जो उसे बेस बनाता है, वो इलेक्ट्रॉन पेयर ही होते हैं. इसीलिए substitution and elimination reaction they become the competing reaction. In some cases it is the substitution product that overcomes, and in some other cases it is the elimination product that overcomes. Fine. After this we need to understand that when we have to give the in a particular reaction the substitution or elimination will take place. सबसे पहले हम बात कर रहे हैं for the halide CH3X. अगर हम CH3X को देखते हैं, हम किसी भी रिएजेंट के साथ इसको रिएक्शन करवाएं, चाहे वो CH3ONa हो, चाहे वो aqueous KOH हो, डेफिनेटली यहाँ पर क्या होने वाला है? There will be the elimination and substitution reaction will उसकी जगह पर यहाँ पे कौन सी रिएक्शन होगी? It is only the substitution reaction that is going to take place. The first important conclusion over here is that CH3X always give the substitution reaction by which mechanism? By SN2 mechanism over here. जब भी हम 1 डिग्री हैलाइड के बारे में बात करेंगे, that is our CH2, that is X over here. So we always say that from 1 degree halide यानी कि primary halide, they always give mainly which reaction over here? They give mainly SN2 reactions. कौन सी reactions देते हैं? SN2 reactions ही देंगे, except in the presence of a strong sterically hindered ion like tertiary butoxide ion. अगर tertiary butoxide ion होगा, ठीक है, टर्शरी बुटॉक्साइड आयन होगा क्योंकि ये स्टेरिकली हिंडर्ड है. इट्स अ वीकर न्यूक्लियोफाइल. जैसे जैसे हिंड्रेंस बढ़ती है तो न्यूक्लियोफिलिसिटी ऑफ द न्यूक्लियोफाइल डिक्रीज हो जाती है. सो इट बिकम अ वीकर न्यूक्लियोफाइल इन दिस केस. इज इट ओके? सो but it is a strong base, and therefore being a strong base it will cause elimination. So the important conclusion over here is that 1 degree halide will be forming the product mainly by SN2 mechanism except in the presence of strong sterically hindered ion, where we say that the product is formed by the elimination reaction, that too by E2 mechanism. I am presuming this thing that you are very well aware of what is SN1, SN2, what is E1 and E2 mechanism over here. So for example, if I am having a halide, that is 1 degree halide, 1 bromopropane I am having, if I am reacting it with CH3, CH2ONA, that is sodium ethoxide, so what is going to happen in this case? It is forming the substitution product over here, और substitution product कौन से mechanism से मिलेगा? It will be forming the substitution product by the SN2 mechanism over here. अगर मैं strong sterically hindered ion लेता हूँ, जैसे कि tertiary butoxide ion लेंगे, so we know that it is a weaker nucleophile, but it is a good base. So it is capable of causing elimination, और elimination कराने के लिए बीटा पोजीशन से हाइड्रोजन को निकालना होगा और ये Cl. So the product is formed by the E2 mechanism and the product formed is propene over here. So 1 degree halide is prominently forming the product by which mechanism over here? They are forming the product by the SN2 mechanism except in the presence of strong sterically hindered ion, which is a weaker nucleophile, but it is a good base. In the first reaction which we have written, where we have formed the ether over here, the alkene becomes the minor product. This will be the major product. In the second reaction, it is alkene that is the major product. So 1 degree halide, I repeat, 1 degree halide will form the product by SN2 predominantly. But in presence of strong sterically hindered ion, the formation of elimination product will take place in this case. Fine. After this, when we talk of the 2 degree halide in this case, 2 degree halides are having the formula as R. This is, in this case, it is RHX. So 2 degree halide किससे product form करते हैं? They form the product by SN2 or they will form the product by E2. There is no possibility of SN1 and E1. The secondary carbocations are of course more stable than the primary carbocations. But in absolute term में जो secondary carbocation है उनकी stability इतनी ज़्यादा नहीं है कि that they will form the product by SN1 mechanism in this case. So 2 degree halides we have taken, and a very simple point over here is strong bases will form the product by E2 mechanism. कौन से mechanism से product form करेंगे? They will form the product by E2 mechanism in this case, like alkoxide ion RO minus gives alkene as the major product in this case. Fine. So that becomes a kind of dehydrohalogenation reaction over here. ठीक है ना? So strong bases like RO minus will give alkene as a product, and the weaker bases कौन से हुए? Weaker bases like I minus, like RCOO minus, ठीक है, like HS minus, which are said to be good nucleophiles also, but they are weaker bases and they will cause the substitution to take place by SN2 mechanism. That is the result for the 2 degree halide. If I take a 2 degree halide as CH3CHBr, 2 bromopropane over here, and I am reacting it with CH3ONA. So what is the product that is formed as a major product? Where I am writing only a single product, I am only writing the major product over there. This is also the reason why we used to say कि विलियमसन ईथर सिंथेसिस में हम लोग हमेशा 1 डिग्री हैलाइड ही प्रेफर करते थे. 2 डिग्री और 3 डिग्री हैलाइड लेते हैं, सो इट कॉज द एलिमिनेशन टू टेक प्लेस ओवर देयर. सिमिलरली अगर मैं एक ये रिएक्शन लिखता हूँ 2 क्लोरोब्यूटेन and I'm reacting it with sodium iodide in acetone. So what it will form the product as, it will form iodine, a reaction which is also called as the Finkelstein reaction. This is again the reaction taking place by which mechanism? SN2 mechanism. Iodine being bigger in size is a good nucleophile, but iodine, because of its larger size, lesser charge density, is a weaker base. So NaI की presence में iodine is a nucleophile causing the substitution reaction to take place, and 2-iodobutane is the product that is formed in this case. Now come the point related to the tertiary alkyl halide, which is having the formula as this. There are 3 alkyl groups that are present over here. The first thing that we should remember over here is there is no SN2 reaction that is going to take place, because SN2 will not occur if there is a hindrance. SN2 के लिए ज़रूरी है कि hindrance ना हो, तो कोई SN2 की possibility यहाँ पे नहीं बनती. In solvolysis, solvolysis are the reactions in which solvent itself participate as one of the reactant. We say that it can give, that is SN1 and E1 mechanism over here. ठीक है. At lower temperatures, SN1 is favored. SN1 is favored. और जब भी हम when the reaction is carried out with a strong base, when a strong base is used, what we observe, like RO minus, elimination occurs by which mechanism over here? Elimination occurs by E2 mechanism. E2 predominancy will be maximum in this case. We know that tertiary halides जो हैं वो product जो हैं, what we can say for them, we can say that they form the product through the carbocation as an intermediate over there. So if suppose I take a tertiary halide and reacting it with methanol, so it is a kind of, if I'm not mentioning the temperature also, I'll consider the temperature as low over here. It will result in the formation of which compound? It will form the product as ether by which mechanism? By SN1 mechanism. So it's a kind of solvolysis reaction forming the product by which mechanism? SN1 mechanism. अगर यही हम tertiary halide, if we would have taken with in presence of CH3O minus, so what is going to happen in this case? We will say that CH3O minus इसका elimination कराएगा by E2 mechanism, and the product formed is, that is isobutene is formed as a product, because these are the beta hydrogen with respect to the chloro group, causing elimination of this. So whenever the question is asked to you about the competition between substitution and elimination, these points will definitely help you. In addition to this, if it is said to you that किसी रिएक्शन में अगर हम ये बात कहते हैं कि in any particular reaction कि you have to compare the order of the SN1 mechanism over there, तो SN1 में कौन faster होगा, कौन slower होगा, in that particular case what do we say? We say that over there check the stability of carbocation, and for SN2 mechanism we say that it is the hindrance that is the point that governs all the thing. So definitely all these factors will help you. I'll come with the next lecture of the organic chemistry very soon. Thank you. Thanks everyone.